Hi, everyone. I am an IR analyst at LaSalle University. I'm presenting on how AI softwares have assisted us to identify students who are at risk for retention. We are an enrollment-based private university with a focus on student retention. However, the challenge is that we are small with limited staff. To ensure retention, we want to figure out how to efficiently identify, track, and engage attrition-risky students. We realized that technology and softwares could help. To understand this better, we did a literature review on how AI and other technologies have been applied in higher education for improving student retention. We found two main applications. First is analytics, including using predictive modeling for early alert and creating dashboards to present action-oriented data analysis. The second aspect is using softwares such as recommendation system and auto-grading, tutoring, and interaction tools like ChatGPT to engage students to support student retention. With that, let's look at a software LaSalle University adopted to improve student retention. It's a service-integrated early alert software called Starfish. I'd like to make it clear that this isn't a promotion of the software, but just a reflection of our experiences. A helpful function of the software is the student watch list. As you can see in the table, each student is given a retention score that indicates the individual's average likelihood to retain within 1 year at LaSalle. To understand how the retention score is calculated, please look at a summarization of the working flow of this software. First, the software is connected to the learning management system, student information system, and other systems like the admission system. Thus, the software has access to students' course data and demographic data. Based on those data sources, a model is built to predict each student's retention score. Students with a low predicted retention score then will be sent to student services teams on campus to identify and support these students proactively. Let's dive into the retention model, which is called gradient-boosted random forest. Random forest is an ensemble of many decision trees, each of which tries to predict students' retention. Each tree is grown from a data sample that is generated through bootstrapping. Bootstrapping is basically resampling data to create different data samples. Each data sample will produce a series of decision trees. Let's look at this example. To feed a data sample, a tree-shaped model will grow, and each node in the tree represents a randomly selected variable from the data sample. The model then predicts retention, and the retention results and the residual will be used to weight the data. To feed the weighted data, a second tree grows. This gradient boosting process repeats until the prediction residual gets very small. All trees need to be considered to make an ensembled prediction that often is more accurate than any single tree prediction. To consistently make accurate predictions, all bootstrapped data samples will be used. So, gradient-boosted random forest is a combination of many strong classifiers. Each strong classifier is produced by a series of gradient-boosted trees. Using this model, we can calculate a student's retention score by simply counting among all the classifiers how many predicted that the student would retain. For details about the model, please search gradient-boosted classification to learn more. The retention model helped us to predict more than 1,000 students' retention probability. The model gives us an average retention score of 88 and students' retention probability ranging from 38 to 99%. It turns out the model has a 81% correct prediction as indicated by area under the curve. In other words, 81% of the time, the model can correctly distinguish a positive outcome from a negative outcome. Also, the small Breer score indicate that the predicted retention probability is close to the real retention probability, which is 0 for not retain and 1 for retain. The retention model not only gives us the retention score of individual students, it also implies important predictors to help identify attrition-risky student groups who have a lower retention score and need special attention from our student services. The first important predictor is no velocity, which is calculated by students' credits earned divided by the median credits earned by all previous college graduates at LaSalle. So velocity indicates the credit earning progress of a student compared to a previous successfully graduated student. Other retention predictors include a low college GPA and credit ratio. Credit ratio means how many credits a student earned divided by the total attempted credits by this student. We also find minority students need to be more supported for improving their retention probability. Additionally, course withdrawal, high school GPA, and being in their first year, as they won't have many credits earned, are also important factors identified by the retention model. Although the software supplies helpful insights on risk factors, and individual student watch list, limitations need to be noted too. The software only uses course and demographic data, but non-academic factors are not indicated and not considered in the model, such as student activity and extracurriculum data, which could influence students' social lives and sense of belonging and contribute to their retention. Moreover, the model is only measured in terms of its prediction performance, but it's unclear whether the software is helping the process of supporting students and ultimately improving student retention. Lastly, we also need to be aware of the ethical issues in any AI-based ad tools. The big data might be biased and the data source might not reflect the whole picture. To conclude, here are some suggestions. LaSalle University used software to predict student retention. It has helped us to identify at-risk students and raise early alerts so that our student services can reach out to students proactively. However, limitations of the retention model reminds us to critically use the tool and seek opportunities to assess the effectiveness of adapting the software. Today, we didn't have the time to cover all the functions of the software, but here are some more features in case you are interested in exploring on your own. The software also have a similar prediction model for completion scores that the software can generate some off-track notifications. They also have analytics dashboards, and there are logs and clicker data available to assess the usage of the software. Here are the citations used in this presentation. Thank you.